All right, how's it going, everyone? Happy New Year, happy holidays, and yeah, welcome back to my streams. I see some familiar faces. Hey, Leonid, how's it going? Nelson, is that book any good? Yeah, we'll get to that in a second. But yeah, we're basically restarting our streams with the first official, I would say, Breakpoint episodes. And today, let me just talk about Breakpoint first and foremost. So this is a streaming series that I decided to introduce in order to diversify the content a little bit. So as you might know, I've usually focused on building, full applications from scratch and, introducing some concepts like clean architecture, domain-driven design, etc. These things are, take a lot of time. And so I'm not only focusing on one specific topic or one specific concept. I thought, you know what, let's just diversify the content a little bit with something like this Breakpoint series that I'm, introducing. And the idea is that we're gonna have multiple activities. For example, today we're going to have CodeCrafters.io, and we're starting the book club. And that's going to, just shake things up a little bit. We're going to talk about more, topics and concepts aside from what I'm streaming on the regular basis. So yeah, just to, diversify the content a little bit. Yeah, Happy New Year, folks. Hey, Vedran, Yaka, and Asaf. Thanks for joining. So yeah, as I mentioned, today we're starting with the book club, and we're going to go through the fundamentals of software architecture. And I got the book right here. It is a pretty thick book, not gonna lie. It is there's a lot to read. But the cool thing is that we're not gonna read it on stream, right? That's problematic in many aspects. We're just gonna summarize it. Basically, I'm reading it before the stream, and I'm pushing on a GitHub repository my understandings and my summarization, and that's how we're gonna go. I definitely suggest you borrow the book from a friend or buy the book, or visit your local library to see if it's there. I'm also gonna post a link to it. There should be one in the repo as well, and just read it up front, right? If all of us read the book, or most of us read the book, and we go into a Breakpoint episode or a book club episode where we talk about the book, it's going to be better. It's not just going to be my perspective on the content. We're going to utilize the chat, or you folks. So yeah, that's the general idea. Hey Harshad, Happy New Year. So yeah, that's the general idea. So we're going to start with the fundamentals of software architecture. I already went through the first chapter. Then we're going to continue to CodeCrafters.io, which is build your own X. It's like a platform that teaches you how to build your own Redis or Docker or Git, etc. And we're gonna start with Redis. All right. So yeah, it's gonna be really fun. Let's just jump in. All right. I'm gonna post the link to the repo here. Let's also make sure that both Twitch and YouTube get the link. Okay, I can see it on YouTube. Great. Nice. Let me know if the link doesn't show up for some reason, because I'm using some experimental tooling right here. All right, yeah. Let's begin. The fundamentals of software architecture. As I mentioned, pretty cool book. This was also picked by the community folks. I posted a poll, and everybody, or most of you, voted for this book. So we are going to, we're going to be dedicating some time to read this book. It's by Mark Richards and Neil Ford, and I think this is the first edition, if I'm not wrong. It is on, let's see, maybe it's the first. Oh, it is the first edition, the February 2020. There seems to be a fourth release, but I only have this one, so shouldn't be too far from the first edition. All right, yeah, let's Everybody has the link to the repo, and yeah, let's just dive in. This is the preface, and it starts like this. It starts like this. Just like mathematics or mathematicians, software architects also build theories on top of axioms. But unlike mathematics, the software ecosystem is dynamic and in a constant change. For example, Kubernetes didn't exist before 2014, but today it has entire conferences dedicated to it, right? When we're talking about software architecture, we're also talking about software architects as like a career, right? As like a job or a role at a company. And the authors in this book, in the preface at least, they're basically saying, you know what, it's pretty much like mathematics. Architects do need to, build theories on top of axioms and also make predictions based on, what how the ecosystem will change, or how the application is going to evolve, or the user base, or the data needs and everything. But unlike mathematics, math is hard truth and it doesn't change. But software changes pretty much every week, right? And that's why they say, like, for example, Kubernetes didn't exist before 2014. And Kubernetes is a great example in this case, because if we're talking about software architecture, we're also talking about, part of it is infrastructure and deployment and CI/CD, and Kubernetes did disrupt that space, right? So before 2014, it didn't exist, right? But there were software architects. But after 2014 and nowadays, it has entire conferences dedicated to it. So as you can see, the software ecosystem changes drastically, right? Just like I mentioned, there were software architects ever, since, I don't know, the dawn of programming, probably. And of course, there are many books and resources on software architecture that predate the current era. And if we're talking about the Kubernetes in the context of Kubernetes and what Kubernetes does, this is not going to be a Kubernetes book, by the way. It's just the example that's given in the book. But yeah, software development didn't look like this. Since the, I don't know, as I mentioned, dawn of the programming. But those books and resources are most likely outdated, right? The authors believe that in order to improve our engineering practices, we must question the fundamental axioms on a regular basis. So as things change and evolve, technologies evolve, we always need to reevaluate our architecture decisions. We always need to circle back and see if the decisions that we've made as architects, the decisions that we've made, I don't know, like 10 years ago or 5 or even 3 years ago, are still holding up today, right? Because maybe something changed in the meantime. We need to be aware of that. Yeah, for example, from starting with extreme programming all the way through CI/CD, DevOps, microservices, containerization, and now even clouds, engineering practices have changed drastically over the years. At some point, software architecture as like a term or a role was understood as the stuff that's hard to change later, right? At some point, people thought that, software architecture, we set it up and we don't change it, right? This is the architecture of the application. This is how it's going to be, and that's it. And we're going to roll with this until the end of time. Well, that also changed with the introduction, for example, of microservices architecture. The change itself is, a first-class design consideration. Nowadays, architects, when they, develop the architecture, especially in the microservices structure, change is built in, right? They are thinking about, okay, this is going to be our initial setup, our initial architecture, but we need to make sure that we can make changes to it, right? That's, for example, microservices and also agile, which we'll touch on it a bit later. But yeah, change is a first-class design consideration. See, like the architects themselves, they're approaching software architecture differently, as as things change in our ecosystem. Yeah, with this book, basically the authors want to address the trade-off analysis. This is another point which is really important, and I've seen it throughout the book. I did glance over the book a little bit. It's a constant theme. Trade-off analysis. Architects must assess the good, the bad, and the ugly of every choice, and because there is no clear choice, there is no no-brainer choice, right? Everything is a trade-off. You get something, but you lose something, and we're gonna see that later when we're gonna talk about. I think it's in a different chapter, but when we're gonna talk about the architecture characteristics, there's gonna be things like security and performance and testability. Those are the ilities. That's how they're called. Hey Tiago, Happy New Year. That's how they're called. There are always trade-offs. For example, if you want to achieve security or very high security, you're gonna have some trouble achieving high performance, right? Because security or high security involves decoding and encoding stuff, and that hurts performance. So everything is a trade-off, right? That's why we need. That's why the authors aim to provide the readers with an analytic eye towards technology choices and also characteristics and decisions. So yeah, that is basically the preface, and I think it's perfect for this book because this is basically what the book is going to be. We're going to look at architectures, we're going to look at or structures, I would say, characteristics, decisions, design patterns, and everything is going to be a trade-off, right? And knowing all of these things as architects, current or future, or hobbyists, I don't know, we need to be aware of everything. We need to be aware of the pros and cons of everything. And when we're making decisions, we need to consider, or have that analytic eye to see the trade-offs, depending on what we want to achieve. All right, so that was the preface. Let's dive into the first chapter, which is the introduction. All right, so first things first, software architecture as a career does not have a clear career path because of several reasons. Like unlike software developers or front-end developers, etc., there is no clear career path for architects because the industry doesn't have a clear definition of what software architecture is. And this is interesting, but there is no clear definition, or there's no one definition, right? When asked the authors of this book, those are Mark Richards and Neil Ford, they refuse to provide a definition for it. Martin Fowler, in his famous white paper, Who Needs an Architect, also refused to define it and used the famous quotes, architecture is about the important stuff, ... whatever that is. And that quote is by Ralph Johnson. I've also linked the Who Needs an Architect white paper here. I haven't read through it, but if anyone does, let's talk about it in the Discord. So the first reason is because the industry does not have a clear definition of what architecture is and what architecture means. Second one is because the software architect's scope of responsibilities is vast, is massive, and it is continuing to expand. So architects themselves have more and more responsibilities. At one point, they only dealt with the technical aspects of the architecture, right? Like how to implement things. But nowadays, their scope includes soft skills, operational awareness, and many other responsibilities aside from the technical abilities. So there was a mind map in the book, and I redrew it because I don't want to, use the actual drawing. So I redrew this, and it's not complete, but this basically shows you what the scope of software architects include. And I'm going to zoom in on this one. So we got, for example, anti-patterns, architecture by implication, witch's brew, big design upfront, last 10% trap. We got visualizations, application architecture, continuous delivery, soft skills, like writing skills, change management, presentation skills. There's also negotiation here, because as an architect, you gotta be, prepared to, or be able to negotiate certain decisions, especially with stakeholders. There's evolutionary architecture, like incremental changes and fitness functions, architectural characteristics, styles of architecture, integration architecture, metrics as well. There's a lot of stuff. So, and this is an incomplete. The mind map in the actual book is a bit more, detailed. So yeah, that is the scope of the architects and the ever-growing scope. And then we have the two more reasons why the career is not defined. Because software evolves rapidly, creating a definition for software architecture today will most likely be outdated in a few years. As we saw, for example, architects before 2014 did not know about Kubernetes, right? But since 2014 on, many of the architects, Kubernetes is like a must-have in their tool belt, right? And it's not just about the technology itself, it's about the like engineering practice, the continuous delivery or continuous integration, right? That is process agnostic, and it doesn't have to be Kubernetes per se, but it's a new thing, right? And architects at some point didn't actually care about that, but now they do. So yeah, that's one more reason why there's no clear career path. And fourth and last, resources and materials on software architecture has only historical relevance. There are things that architects have tried, only to realize the damaging side effects of some of them later. And if you're reading older software architecture books, some of the practices might be labeled as, yeah, this is what it is, this is how it should be done, or this is how we're doing it. But it's an outdated material, or it's an outdated book. This one is from 2020 and it's already 2025. So this might be an outdated book as well. We should have that in mind. But yeah, maybe a lot of those practices are already outdated and they don't apply to modern or up-to-date software engineering, today's software engineering. So yeah, solutions that were once valid cannot work now because the context has changed. So the authors have tried to define software architecture in this book just so we can have something of a concept to talk about. And they define it, some of architects think of the architecture as the blueprint of the system, like this is how we're doing things. But others have, see it as the roadmap for developing the system. The issue lies in understanding what both the blueprint and the roadmap actually contain. Right? What is the blueprint and what is the roadmap? When the architect analyzes the architecture, what exactly is analyzed? So the authors decided to define the software architecture. Define software architecture as like a combination of four things. We have structure, architecture characteristics, the illithies that I talked about a bit earlier, architecture decisions, and also design principles. Also, if you have any experiences or thoughts about this, feel free to drop a line in the chat. We're gonna go through messages as they show up. Okay, there's not gonna be a Q&A at the end. So yeah, all right, structure, characteristics, decisions, and design principles. These four things is what constructs the blueprint or the roadmap. What is, the architecture or the deliverables, for example. You can look at them like that. And let's look at them. Structure is the architecture style. For example, like microservices, layered architecture, microkernel, clean architecture. When we're talking about clean architecture or microservices architecture, we're talking about the structure or the organization of code, right? Of how things are implemented. And structure does not define the architecture itself, because there's more to architecture than just microservice architecture, right? If we say application is built with microservices architecture, we're referring to the structure, not the overall architecture. we have a question. How is it different from system design? That's actually a good question. I think there's a lot of overlap. Maybe I'm not sure what system designers or the role of system designers of what everything is, in the system design role. So to me, again, I'm not an expert in this. I'm not an architect myself. I'm just reading the book along with all of you. But I think there's a lot of overlap in system design and, software architecture. Maybe it's even the same thing. As you can see, there's no clear definition of software architecture. So some people might say, oh yeah, that's basically system design. Or maybe it's not. I don't know. But it's an interesting question to think about. If anyone knows, please, drop a line and answer the question. So yeah, we're talking about the structure when we say microservices architecture or layered or microkernel, etc. Then we have the architectural characteristics, and these are very important, and these are called the ILTs. Availability, reliability, testability, scalability, security, agility, fault tolerance, elasticity, recoverability, performance, deployability, learnability. As you can see, these are things that they're not implementation details, right? We're not talking about code organization. We're talking about the structure. We're talking about aspects of our architecture or our system that we want to achieve, right? We're interested in security because the nature of the application that we're working on is, we're dealing with some sensitive data. So security is the number one priority, right? Or one of the must-have characteristics. Or for example, we need testability because the team that we're working with is a TDD team, or I don't know, right? Depending on all of the external factors and all of the nature of the application, and also like the wishes of the stakeholders themselves. These are the characteristics that we want to, achieve in our architecture. And they define the success criteria of the system, which is independent of the system's functionality, right? Regardless of if we're talking about microservices or not, we need security, right? Or we need performance, high performance, because we need, or our application must be performant. For example, microservices or not, basically I said this, microservices or not, if you want to support testability, we need to design our software to be testable or easily testable, right? If we're writing all of our code into one application and we're not into one file, for example, and we're not paying attention to the structure, we cannot achieve testability, right? At least, for example, unit testing, we can only achieve other types of testing. So have we achieved testability? I wouldn't say so. So if we say that our application must be testable, the testability architecture characteristics somehow dictates, the structure, right? That's basically the correlation and how, structure and characteristics and decisions and design principles work with each other. Okay, next we have architecture decisions. And these are basically rules of how a system should be constructed. These are more implementation details, and these are basically rules. That doesn't mean that the rules that are not meant to be broken, these can be broken, but for example, architecture decisions look like we will prevent the, for example, we can make a decision that only the business and services layer in a layered architecture, if we choose layered architecture as the structure of our application, only the business and services layers can access the database, and we're going to prevent the presentation layer from directly querying the database, right? For example, this might be due to the fact that we need security in our application, right? So we are preventing the presentation layer, which is the UI or the API endpoints or the mobile application front end, whatever we're working on, doesn't matter. We're preventing the front end the interface itself, from directly accessing the database. Why? Because we chose security as one of the core characteristics that we aim to achieve, right? So yeah, that is a rule. The architect or the chief architect puts these design architecture decisions, and it doesn't mean that they cannot be broken, right? They basically form constraints and inform the development teams that what it is and what isn't allowed, right? And they can be broken through variances. Dev teams can submit a variance request for a specific standard or decision. Explain why it needs to be broken or why it can't be implemented that way. And that variant can either be accepted or denied by the chief architect or by the architecture review board if it exists within the company. So there is a communication mechanism through so-called variances where the development team can request a certain rule or a certain decision, architectural decision, to be broken. And yeah, those are called variances. And then we have design principles, which are similar to decisions, but they're more guidelines rather than rules, right? They're not constraints. They're more like, you can, for example, in order to increase performance, the architect can suggest the dev teams to leverage async messaging between services within a microservice architecture, right? These are just design principles. These are just guidelines for the dev teams. Basically, like when you're implementing the microservices, it's a good idea to leverage async messaging, right? For example, implement Kafka, and not a mechanism that allows one microservice to trigger a function directly in a different microservice and wait for the execution. While an architectural decision is, constraints, design principles allow more freedom to developers to choose an appropriate solution, right? I mentioned Kafka. In the case of async messaging, the design principle doesn't really impose a specific technology. The development team can, choose the most appropriate solution or technology for that case, right? Whether they're going to be using Kafka or something else, that's up to them. That's just a design principle, a guideline. Okay, so when we're talking about, in this book, when we're talking about software architecture, we're going to be talking about these 4 things: the structure, the characteristics, the decisions, which were rules, hard rules, and design principles, which were guidelines. All right? Let's look at the expectations of an architect. Defining the role of the architect is equally difficult as to define software architecture itself. But regardless of the definition, there's actually a typo. Yeah, someone can fix this. There's an opportunity to open a PR. But regardless of the definition, there are 8 core expectations of software architects, and you might be blown away by some of these. The first one is, of course, the architect is expected to make architecture decisions, right? So that's like the number 1 expectation. That's the job as we know it. An architect is expected to define the architectural decisions and design principles used to guide technology decisions within the team, the department, or across the enterprise. And the key word here is guide, right? The architect should guide rather than specify technology choices. Really important. For example, an architect shouldn't make a decision to use React.js, right? That's not the role of the architect. The architect, that's a technical decision. That's not an architectural or architecture decision. The architect instead can suggest the team to use a reactive-based framework, and that leaves the choice to the team to pick between React, Angular, Vue, Svelte, or whatever the team is, most or has the most expertise with. But the reason behind, the reactive-based framework might be a certain characteristics, might be performance, or might be, something else. Basically, the architect should not impose, you're gonna use React to the dev team, rather than should guide. That's why the keywords of this definition was guide instead of specify or force. But yeah, it's also not uncommon for an architect to make a specific technical decision, like you should definitely use React in this case, in order to preserve a specific characteristic such as scalability or performance, right? We've known, for example, in React, in the React ecosystem, we've seen some performance discussions. And when new frameworks like Svelte or Solid.js came out, especially then the topic of performance and how much JavaScript we ship to the browser and SSR, and server-side rendering and stuff like that. That was a common topic to be seen on Twitter that time and maybe even today. So yeah, the architect can make a technical decision. Like we cannot use React in this case. Why? Because this and this and this and this, right? All the reasons why. Because we're trying to achieve something, achieve some characteristics. But yeah, the main idea is the architect to guide, but they can also make technical decisions or like impose a specific technology in order to preserve a specific characteristic. All right, that is the first expectation. Then we have to continually analyze the architecture. An architect is expected to continually analyze the architecture and the current technology environments, and then recommend solutions for improvement. This expectation refers to architecture vitality. The architect needs to assess how viable the architecture is today, how viable the architecture today is the architecture today that was defined 3 or more years ago. And I touched a bit on this earlier, right? The continuous improvement, the continuous circling back, making sure that the decisions that you as an architect or someone else in the company have made are still holding up in today's climates, like I don't know, 3 or 5 years later. Not adapting to architecture leaves room for structural decay, which occurs when developers make design changes that impact architectural characteristics, right? This indicates a different expectation, which is this one. And we'll talk about that just after this one. So another expectation is to keep up with the latest trends. An architect is expected to keep current with the latest technology and industry trends. Just like the developers, architect too need to keep up to date with the latest technologies. The architect's decision is usually long-lasting and difficult to change. It's not impossible, like the industry have thought previously, like this is the architecture and this doesn't change. Yes, it does change. But does it change easily? That's up to discussion, right? Usually, or oftentimes, it is difficult to change a decision. Being up to date helps the architect prepare for the future and make correct decisions, right? And then we have ensure compliance and experience. An architect is expected to ensure compliance with architecture decisions and principles. This basically means oh yeah, there we go. The architect makes sure that the development team is following the architecture decisions and design principles that are defined, documented, and communicated by the architect. The architect can measure compliance using automated fitness functions and other tools. And I think there was a whole chapter on fitness functions themselves and like how you as an architect can make sure that the development team is basically implementing or sticking to the architecture that you have made or you have defined. And I think there should definitely be some more details on fitness functions. Yeah, there we go. It's in chapter 6, so it's gonna take some time, but yeah, we're eventually going to go through fitness functions and learn how we can measure compliance on the architecture that we as architects define. Next, we have diverse exposure and experience. Oh, there we go. So And experience, there's another typo. So if anyone's up, can make a PR and just remove this. It should just be actually this one. Ensure compliance. But yeah, let's talk about the diverse exposure. This is an interesting aspect, and it's something that's usually different than software engineers themselves. An architect is expected to have exposure to multiple and diverse technologies, frameworks, platforms, and environments. It's not expected to be an expert in everything, but to be familiar with a variety of technologies. In order to fulfill this expectation, the architect needs to stretch their comfort zone. An effective software architect seeks to gain experience in multiple languages, multiple platforms, and technologies, right? We're talking about breadth. We're not talking about depth. We're not talking about specialty. We're talking about being a generalist, not a specialist. Yeah. For example, it's more valuable for an architect to be familiar with 10 different caching products, at least know their pros and cons, rather than an expert in only one of them, right? Because it is not expected for not always expected for the software architect to implement these things, but to make the decision. And you don't need to be an expert to know how to, every implementation detail of a certain caching product. You just need to know their pros and cons and how they evolve in order to make the decision, right? Someone else is going to implement that. The developers will implement that, for example. So yeah, diverse exposure and experience. Another expectation is to have business domain knowledge. An architect is expected to have a certain level of business domain expertise. The business domain can influence certain architecture decisions or characteristics. So it's important for an architect to have a business domain knowledge. Let's talk briefly about this. We're talking about, you being an architect in a specific, in a project that solves a specific problem. Let's say that it's an e-commerce website that is for a chain of restaurants, right? If we're talking about characteristics, we're talking about scalability, availability, right? And elasticity. And those three can matter, or those three can be influenced by the business itself. For example, if the restaurant has stores only on the East Coast, the deployment of the application is going to look differently. Rather, in contrast, if the restaurant franchise or the chain or the chain itself has restaurants all across the world, right? If we're talking about availability, we need availability in all of the continents, pretty much, except Antarctica maybe, or whatever the restaurant has presence or stores. But if we're talking about elasticity, elasticity means the architecture or the system itself being able to handle a sudden burst of users, right? If for example we're talking about the working class ordering breakfast at 9 a.m., the system needs to be able to handle that, right? Because usually everyone orders breakfast at, 9 to 10 to 10:30, right? So elasticity means being able to handle a burst of users. And if that means there are users only on the East Coast, you're going to implement sharding or replica sets only in the East Coast in order to handle that. And the elasticity and availability is in that time zone. But if it's on the whole, across the whole world, it's a different thing. So that's why it's important for architects to have business domain knowledge. And that's just like one aspect. Of course, that's not the business domain knowledge that I'm talking about. It's just one aspect of it. It's also needed to communicate. Yeah, having a business domain expertise is also needed to communicate effectively with stakeholders, with C-level executives, and business users. Otherwise, the architect will quickly lose credibility. And this is also really important, right? If you don't, as an architect, if you don't have the the business domain expertise, if you don't know what the business does and the ins and outs of the application itself, the users of the business itself, you can really communicate effectively with the stakeholders. And if you don't, you're not gonna have their trust, I would say, right? You're gonna lose credibility. And if you don't have credibility and you make a certain architectural decision, like we're going to go serverless and we, instead of monolith on a VPS, they're gonna ask you what's the pros and cons. You're gonna say, well, we're gonna achieve elasticity much better if we're on a serverless setup with auto scaling on, for example, on AWS. But that means the sudden burst of users will also increase the costs. So when you loop in money, when you put money on the table, like it's going to increase costs or maybe decrease cost. I don't know. When you put money on the table and you don't have trust and credibility, they're just going to, decline. They're going to say, no, we're actually going to keep the monolith. We're not going to invest, or we're not going to allow flexible budget. We have this much budget and you can't really work around that. So that's why it's also important to, as an architect, to maintain that credibility and to gain the trust with the stakeholders. We got some questions from Indica and Philip. What happened to the AI resume application live streams? We might put a pause on them because I have another project that I need to work on. But we might continue, working on them later. And Philip says, if I'm using Obsidian in NeoVim, no, I'm just using Obsidian, just as Obsidian. I'm not using it in NeoVim. Right, let's proceed. Also, an architect is expected to possess interpersonal skills. Exceptional interpersonal skills, including teamwork, facilitation, and leadership. And this is one of the more difficult expectations to maintain and to keep up, I would say. There's a quote by Gerald Weinberg: no matter what they tell you, it's always a people problem. I love this. An architect is expected to lead the development team through the implementation of the architecture, right? You as an architect define the four aspects: the structure, the characteristics, the decisions, and the design principles. But you're expected to be like the technical lead and to consult and, to lead the development team on how to implement these things. You're not going to be implementing them. You're not going to be, maybe depending on the role within the company, but you are expected to lead them. So that's why, teamwork, leadership, facilitation, that's why it's a huge expectation from software architects. And of course, it's a great skill to differentiate yourself when you're searching for an architecture job, right? And lastly, understanding and navigating politics. This is a weird one, but it makes sense. An architect is expected to understand the political climate of the enterprise, the company, and be able to navigate the politics. First, I was like, what? But it does make sense. Almost every decision an architect makes will be challenged. You're making a decision. We're moving from monolith to microservices, etc. There's going to be people screaming at you or questioning your decision or trying to, prove you wrong, basically. And those are going to be like the product owners, the project managers, the developers, and even like the stakeholders themselves due to increased costs or increased effort. Right? In all cases, the architect must navigate the politics of the company and apply their negotiation skills to get most of their architecture decisions approved. That's why it makes sense, right? To be able to understand and navigate the politics. Because again, it is, I'm going to circle back to the Gerald quote. No matter what they tell you, it's always a people problem. If you want to make an architectural decision, that is sound and logical and, good for the software, it's going to be challenged. And you will have to be prepared to negotiate or even have like a trade-off. Like, okay, if we're not implementing this then plan B is this. So yeah, that's why the last expectation is interesting, but it does make sense. Okay. Inika says, can you make available the streams on YouTube? I will. I set them as unlisted for, temporarily, just because I was looking at YouTube analytics and stuff, but I will bring them back. All right, the next section in the first chapter is the intersection of architecture and a bunch of other roles and departments. We're talking about engineering practices. So the intersection of architecture and engineering practices. The book says there's a difference between development process and engineering practices. Process is the mechanics of how people organize and interact with each other, like how meetings are conducted, how teams are formed, workflow organization, etc. That's all process. On the other hand, engineering practices refers to process agnostic practices that have repeatable benefits. And one example of an engineering practice is continuous integration, right? The architects must ensure that the architectural style they picked and the engineering practices form a symbiotic mesh. For example, microservices architecture, right, as the structure of the architecture, assumes automated machine provisioning and automated testing and deployment, right? Continuous integration. That is continuous integration, and that is also engineering practices. So the architect says microservices architecture, and the engineering says, yeah, we need continuous integration, right? The architects must integrate engineering practices with architectural decisions to ensure cohesion and success. For example, if you as an architect want to make sure, want to pick let's go with the same example, the microservice architecture, but you're not aware of the concept of continuous integration and all of these things. How will you be successful in your job if you're not aware of engineering practices, right? And this is basically the intersection where these two disciplines collide. Due to the fact that in software development, predicting structural changes upfront is hard, that developers are bad at estimation due to unknown unknowns, and that it's impossible for architect to design for unknown unknowns, an agile and iterative development process aligns better with architecture. This is a different point. It's not the same as the previous one, so I should have put a paragraph there. But basically, this basically says another, intersection or another common point between architecture and engineering practices is, for example, agile and iterative development processes. They align better with architecture because of the unknown unknowns. There's an example like the software engineering as an engineering discipline is not as mature as, for example, civil engineering, right? They're more capable of predicting changes in the future or certain events than we are, because the software development industry is, as we've mentioned probably 100 times at this point, it's ever changing, right? It's dynamic, it's in constant change, and there are always unknown unknowns, right? So, and because of them, another intersection of architecture and engineering practices is like methodologies like agile, right? Iterative development process. So those are the two. Now let's get into the operations and DevOps. Historically, operations have been considered as a separate function and often outsourced. And we're talking about operations as like DevOps or sysadmins, etc. And because of that, architects couldn't control operations and had to design defensively around that restriction. And that resulted in vastly more complex architectures. This means, for example, if the operations or DevOps are outsourced and you as an architect don't have control or don't have influence or a way to ask things, right? In order to achieve something, you would need to basically implement those things within the architecture itself. And that complicates the architecture. We're talking about the DevOps team being outside, being capable only on of achieving certain things. I don't know, managing VPSs and working with monoliths, but you want microservices, and they're not going to implement that, but you need microservices because of several reasons. In order to still achieve the characteristics that you want to achieve, you need to basically build them in a monolith structure. That's going to complicate your architecture. So that's how it has been historically. To address this, many companies started experimenting with new forms of architecture that combine many operational concerns with the architecture itself. For example, in older styles architectures like ESB-driven service-oriented architecture, handling things like elastic scaling meant building them inside of the architecture itself, which greatly complicated it. Nowadays, in contrast to this, microservice architects realize that things like elasticity and scalability are best handled by the operations team, right? You as an architect will just define, this is going to be a microservices architecture because we need to handle elasticity. You're going to define a bunch of this architecture decisions and design patterns, guidelines, and rules of how things should be within the application on the architecture, and you will give those to the operations team or the DevOps team and have them implement the infrastructure that supports elasticity and scalability. You're not going to be manually building that in the architecture itself. So by creating a liaison or a common ground between architecture and operations, that's the intersection, architects can simplify their design and rely on operations or ops for the things they handle best. So that's the intersection of architecture and operations. Then we have two more: process. The process that development team uses has impact on many facets of software architecture. As we mentioned, agile, right? Agile projects can assume iterative development. We're not talking about waterfall, where we plan ahead. I think that was the big design upfront aspect that we mentioned previously in the mind map. We plan ahead for the whole year of development, and we stick to that plan, right? That's waterfall. That means changes are not welcome. But agile, on the other hand, it's a different process. It is more iterative. That creates faster feedback loop for decisions, right? That's how that's how the process itself can influence architecture, because it'll allow the architects to be more aggressive about experimentations, right? Architects nowadays can say, let's try this out, right? Let's see what kind of performance can we achieve from by setting these specific decisions, and then we can change later on if we make a bad decision. Revert it, fix it, right? That's the intersection between the process or methodologies and architecture itself. All architecture becomes iterative. It's just a matter of time. And this is a quote by Mark Richards, one of the authors of this book. Unless we have data, not much to talk about here. The intersection between architecture and data, it's an obvious one, right? Code and data have a symbiotic relationship. One isn't useful without the other. Data, when we're talking about data, we think about databases, but it's not just like databases. We're talking about like databases, we're talking about storage, caching is also there. Maybe it's like a mechanism, etc. Database admins work with architects to build data architecture for complex systems, right? If you're working on a project, or if you're an architect on a project that has a huge, data flow. For example, I'm not an architect, but I work at Sentry, and Sentry is a SaaS that receives a whole bunch of events like crash reports, monitoring metrics, and data like that from thousands and thousands of projects. The architect at Sentry needs to take into account how the architecture will handle all of that data, right? Because there's a lot of data coming in, and how it's going to be processed, and how it's going to be stored, and then how it's going to be retrieved for further processing or aggregating. That's the intersection between architecture and data, basically. All right. We have all this thing, the 2 laws of software architecture, and that's going to be the end of chapter 1. So there are 2 laws, and these are really important. This basically, in a way, it summarizes everything that we've went through until this point. So the first law of software architecture is everything in software architecture is a trade-off. There is no clear choice. There's no, hey, this is a no-brainer, we're definitely going to use this. No, you gain something, but you lose something. As an architect, the decisions that you make are always going to be you gain something, you lose something. But the right decisions are losing something that you can afford to lose in order to gain something that's going to make your application successful, right? That's architecture. And there's also a corollary one, or like a supplement, an appendix to the first law. If an architect thinks they've discovered something that isn't a trade-off, it's more likely that they just haven't identified the trade-off yet. Okay? And the second law of software architecture is why, and this should have been italic, not this whole part, but why is more important than how. Okay? Architecture is defined beyond structural scaffolding. We're talking about architecture is not just, the microservices or layered architecture or clean architecture. It incorporates principles, characteristics, and so on. It's broader than just the combination of structural elements or just code organization. We're not talking about software architecture as just how do we make the folders in our application. That's not the whole thing. An architect can look at an existing system and identify how the structure works, but will struggle to explain why certain decisions were made. That's why is more important than how. Right? You're an architect that just got onboarded to a new project. There were other architects before. They have made a decision on using, microservices. And if it's not documented, or if it's not known why, you're not going to know the reason behind it. And if you want to change that, using the first law, everything is a trade-off. If you want to change that, you're going to gain something else, but you might lose something that you're not even aware of, right? So that's why is more important than how. Yeah, these are the first 2 laws of software architecture. And this is basically going to be the book, right? Maybe I should have shown, okay, let me do this. Maybe I should have shown the table of contents. Actually, yeah, let's do it next Wednesday on the next stream. This is basically just an introduction to the book. You can check it out on this link right here. Yeah, it's part of the repo. I'm gonna share the repo link again for all of you watching to just get it, start reading it, find this book, check out the table of contents. And I'm actually going to, after this stream, I'm actually going to go through the table of contents of this book, and I'm going to put it into the README, just so you know what we're going to be going through. Okay? Yeah, should have done that before I started streaming, but doesn't matter. It's going to be cool. Right, so that's that was the first chapter. If you have any questions, yeah, feel free to drop a line in the chat here or join my Discord, because there is a book club channel. It's creatures.sh. There is a book club channel where you can post any questions that you might have around this book. So yeah, the next chapter, we're going to be covering it next Wednesday, because we're doing this every Wednesday at the same time. All right, this was fun. Yeah, hope you enjoyed it. We have a question. What does your process of coming up with these notes look like? Do you read, underline, and then try to paraphrase? Curious. I read the chapter. First, I glanced through the chapter. I don't read like word by word. I just like scan the chapter just so I can familiarize myself with what the chapter is going to be. Then I go back and I reread it, and I just try to understand what is like what is the key point that the authors are trying to tell me in this chapter. And I don't think I have refined that process yet. For example, if you look at the way that I've taken these notes, some of them are more like bullet points and lists, whereas these ones are more like paragraphs and text. I think that was like, in the moment, I thought to, it's best if I explained this using bullet points or an ordered list. But in this case, I thought, maybe it's better if I just type some text in. I am still to refine this process of, reading and taking notes and, summarizing things. But yeah, I guess I'm just going to get better as we go through these chapters. But I don't have any, like, within the book, I don't like to, you're not going to be able to see this because it's like overly exposed. But yeah, there's no notes, there's no ink in this book, only the things that are printed. So yeah, that's how I try to attack this. But I'll get better. All right. Next thing that we have, the next thing that we want to do is activity. And we're basically going to go through the CodeCrafters.io. I'm actually drop a link. I'm just going to type it in manually. We're going to go through the CodeCrafters.io catalog and just try to implement stuff ourselves. As you can see, you can build your own HTTP server, and I've done this, I think, with Golang. There we go. Yeah, I used Go to implement an HTTP server from scratch. But we can build our own shell, our own interpreter, our own grep, Redis, Kafka, SQLite, Git, BitTorrent, DNS server, and we can do it in any language that we want to do it. There are like certain languages that are supported by CodeCrafters, but basically we picked to build our own Redis in JavaScript for this as the first CodeCrafters project. And I think we might stick to JavaScript or TypeScript. We can see that TypeScript is supported. Unless someone thinks, hey, let's try our hand to implement this in Go or in Python, or we want to learn Kotlin, so let's try Kotlin, right? The good thing about this is that you learn the language and design patterns, and you basically learn software engineering the best if you're trying to build something concrete rather than just reading the docs and memorizing things, right? We don't become engineers by memorizing stuff. We become engineers by building stuff, breaking them, and fixing them. So CodeCrafters basically, put an accent on that. So they built this wonderful catalog of different projects that teach you how to build specific things. So we're going to start with Redis. We're going to learn about TCP servers, the Redis protocol, and more. And we're going to try to do that in TypeScript, right? Let's see. I am most comfortable with TypeScript. I would say TypeScript may not be like the best language for this type of project, but we're not going to actually build a Redis competitor. We just want to go through the process of building Redis itself and seeing how, seeing what we can learn from it. Of course, it's going to be much faster if you build Redis in Go or Rust rather than JavaScript. but we're not aiming for performance in this case, at least compared to other languages. We just want to build Redis and see what we can learn from it, right? So let's begin. Yeah. Redis is an in-memory data structure store often used as a database, cache, message broker, and a streaming engine. Let me actually zoom in a little bit. There we go. In this challenge, you'll build your own Redis server that is capable of serving basic commands, reading RDB files, and more. Along the way, you'll learn about TCP servers, the Redis protocol, and more. And full disclosure, I haven't done this. And I haven't even had an extensive experience with Redis, personally. So this is going to be, a lot of figuring out, reading about stuff, using ChatGPT, to summarize and explain a bunch of stuff. So yeah, let's give it a go. I'm actually gonna go on GitHub now. So we are already there. I'm gonna create a new project, a new repository, and I'll name this Redis JavaScript, or just Redis CodeCrafters. If we do more, we'll do CodeCrafters first, and then Redis, and then JavaScript, which is JS, okay? Implementing Redis CodeCrafters.io with JavaScript, or let's do TypeScript instead, because there is a difference, at least in CodeCrafters. So this is going to be redis.ts. There we go. I'm gonna create this repository and immediately share it with the chat. It's not that there's gonna be anything inside, it's just that, there we go. All right, so there's quite, some lessons. I think there was like 55 stages. So let's see. Introduction. Oh, there we go. We start from the very beginning. And we're gonna do this by just before 11 p.m. because I have a hard stop at 11. All right, welcome to Build Your Own Redis Challenge. Redis is an in-memory data structure store, often used as a database, cache, message broker, and streaming engine. We already went through this. Redis server, capable of basic commands, TCP servers, etc. All right, so which language would you like to use? We're gonna use TypeScript. There we go. Now we're in Build Your Own Redis TypeScript. How would you describe your experience level with TypeScript? We can tell your experience accordingly. I'm gonna be like critical and say intermediate, although might be advanced. I don't know. We'll just say intermediate. Okay. Next question. How often do you intend to practice? This is gonna be once a week during these streams. So yeah. Would you like us to send you an occasional friendly nudges to help you stay accountable? I'm gonna pass because I have you folks for accountability. Okay. All right. So there was already a starter repository. We just need to clone this, cd into it, and push an empty commit. Okay. Redis TypeScript. Hold on, let me just prepare. I'm gonna open Western, cd into projects and my own. You know what? Oh, okay. It initializes a new project for you, apparently. So I'm gonna delete this CodeCrafters Redis TS, and I'm gonna create a new one with the command. Code mods or home row mods. There we go. Okay, sign in. Right. Now, we're already in the directory. Let's just clone CodeCrafters Redis TypeScript, cd into CodeCrafters Redis TypeScript, and we need to push an empty commit. But there's already a git, of course, git remote show origin. Oh, it's on codecrafters.io. Okay, interesting. Interesting. Okay, so I can't actually share my repo, or maybe I can later. We'll see. We can have two remotes and push to both remotes. This one is probably because we want, you know, to give our code to CodeCrafters so they can test it out and see if we passed or implemented the things. Yeah, let's just go with the flow and see what's up. Let's just push an empty commit here. There we go. Welcome to CodeCrafters. Your commit was received. Yes, there are tests as well. Appear shortly. Moved CodeCrafters to your program. Compilation successful. Failed to connect to port 6379 because we don't have anything. Redis. Yeah. And these are the instructions. Cool. All right, so we've done that. The listening for a git push message will change and the first stage will be activated. So are we there yet? There we go. You've completed the setup. Moving on. All right. If you have any questions, don't hesitate to reach out. I'm keeping an eye on the chat right here. All right, so since this is the first stage, we have included some commented code to help you get started. So past this stage, simply uncomment the code and submit your changes. Step 1, navigate to main.ts. And let me actually open Vim here. App main.ts. There's main.ts. And it says to uncomment navigate. Okay, I have navigated. Uncomment the console log and the server listen. Okay, so console log is already commented out. We need the server listen. I'll save this. And then we need to submit the changes. Okay, let's try to do that. Oh, hold on, I didn't actually create a tmux. So tmux new as CodeCrafters Redis TypeScript. I'm gonna open Vim here, and then we're gonna create a new window here and just say uncommenting stuff. I guess it doesn't matter because this is not a public repo. And then just git push origin master. Running tests. Now it was able to connect to that port because we have uncommented out the uncommented this part right here. There we go. Yeah, this is all done. Next stage. And this is how we're basically gonna go through, you know, the whole course. So stage 1 of 55 done. All right, response to ping. In this stage, you'll implement your own solution. Unlike stage 1, your repository doesn't contain commented out code. 98% of the users who attempted this stage completed it. All right, so head over to your editor and implement your solution. Okay, but what do we need to do? Response to ping. We can do this basically. We have a create server here. Connection dots. Do we have types? Because this is from the net.socket. I don't see any types here. Oh, it is any. Well, hold on a second. I didn't do npm install. How can I? Damn it. Let's npm install this. And there we go. There we go. And now we do have the type. So connection dot. There we go. Find and emit drop. We have all of these stuff. There's connect, compose, connecting, read. Right. So logs from your program will appear here. Let's just do console.log connection. And is there a way to trigger these unit tests? Because if there are, oh, this uses bun actually. You see that? I do have bun, yeah. Bun install. There we go. There we go. I just want to console log the connection here. And can we... I don't want to look at the solution just yet. You'll implement... So there is actually the task. You'll implement support for the ping command. Redis clients communicate with Redis servers by sending commands. For each command, a Redis server sends a response back to the client. Commands and responses are both encoded using the Redis protocol. We'll learn about that in the later stages. Ping is one of the simplest Redis commands. It's used to check whether a Redis server is healthy. It's just a ping, right? The response for the ping command is +pong and then /r/newline. This is the string pong encoded using the Redis protocol. In this stage, we'll cut corners by ignoring client input and hard coding pong as a response. So, yeah. The tester will execute your program like this, your program.sh. I think we have that. Yeah, your program.sh, that's here. It'll then send a ping command to your server and expect a +pong response. Your server should respond with +pong, which is blah blah blah. We've already seen this. You can ignore the data that the tester sends you for this stage. We'll get the parsing client later. Okay, so we just basically need to return pong as a string. The exact bytes of your program will receive won't be just ping as a string. You will receive something like this, basically, which is the Redis protocol encoding of the ping command. We'll learn about this later in the stages. So that's why we're not handling user input because we don't have a decoder. We're gonna probably build that later. In this case, I just need to use the connection to return, to send or return. How's the, let's see, node net socket. I want to say the docs, and this is the ping command. It also gave us a link to the ping command itself. Net server, this is the net server. Connection listener, this is the listener itself for the connection event, and it returns the server. And then we have the connection object, which is the net socket. So let's check that one out. It's an abstraction of a TCP socket for streaming IPC endpoint. It's also an event emitter. It's created by the create connection server. Let's see the options. Close, connect, data. So the data event is emitted when the data is received. So we're probably going to use this later to say, I don't know, connection.data, and then pass in a callback. The argument data will be a buffer or a string. Encoding data is set. We can actually use this. Let's say I want to print out the data that we receive and see if it's something like this. You know, it's going to be like, it's going to be bytes probably. Event orders on. There is on. Yeah, okay, so on data, we have a listener. It's going to be of type buffer. And I just want to console.log data, and then the data itself, but this is a buffer, so we need to read it. So we probably need a stream. Let's see. Let's use AI. I'm actually going to select this and then give it to the plugin and ask, and you can't see this, but actually let me fix that real quick. Can we read the buffer synchronously before printing its contents? I mean, we can, but like how? Yes, we can. Of course we can. Let's bring back the camera. Oh, just do string, basically. interesting. So we're gonna print out the string, and let's actually just invoke the yourprogram.sh. Logs from your program will appear here. It's not even doing anything. So we should have a server handle the connection. There was a different event. That's the connect. Let's see. Connection dot on connect. We have just a plain listener. Okay. I don't see how we're testing this. CodeCrafters trigger tests. Oh, there's a CLI, CodeCrafters tests. Let's do that. CodeCrafters test. Okay, I got the CodeCrafters tests. Okay, so check this out. We have data *1 $4 ping. Okay, that's basically what we want to see. And yeah, of course, if you're following along, make sure that you install and use the CLI. It's been some time since I've done the HTTP server in Go, so yeah, there is a CLI, and we're gonna use CodeCrafters tests to test out. But I think we're seeing stuff, right? *1. Then we had an RN new line, $4 RN new line, and these are printed. As you can see, we have the R, I can't remember what it was called, but it is here, and there's also a new line, the $4, again, a new line, and pink. And then a new line. Cool, and we should just return ponk. But it logs everything. Yeah, there is no onConnect, as you can see, but everything else is here. I'm just gonna remove this. We can see the data, but we should say connection dot. How do we send? How do we send back? Data is received. Drain ends when the other end of the socket ends the transmission, thus ending the readable side of the socket. Ready to be used. Buffer size. It's probably going to be here. Connect ends. Half closes the socket. It sends a fin packet. It is possible the server will still send some data. Okay, so this is one way of sending data back to the client. But there should be another one. That's what this is telling me. Set encoding. Keep alive, no delay. Set timeout, timeout. Unref, write. Sends data on the socket. There we go. The second parameter specifies the encoding in the case of a string. It defaults to UTF-8. Returns true if the entire data was flushed successfully to the kernel buffer. Returns false if all or part of the data was queued in user memory. Drain will be emitted when the buffer is again free. Okay. So we just do write. We need to send a buffer, and I think we can immediately send data, and we don't need a callback, right? And we should send this plus ponk and then the /r. Let's actually ask the robot what is the /r called. And what is it used for? Let's learn about /r. A carriage return. So it is called a carriage return character. It's used to move the cursor to the beginning of the line without advancing to the next line. In combination with the new line character, it is often used to signify the end of a line of text in the network protocols and text files. So it's just basically new line, but it's with the carriage return. In the context of network communication, RN is commonly used as a line terminator to indicate the end of a command or response. For example, in the provided code, plus ponk RN is sent to the client to indicate the end of the response message. Cool. All right, so if I run CodeCrafters test, this is gonna pass, right? Let's see. Test passed. Beautiful. CodeCrafters submit. There we go. Let's move on to the next step. Nice. Kind of like this. This is a good experience on CodeCrafters. Okay, we've done this. Beautiful. How do we do? I love that. Yeah. Wait, what is that? Test failed. I think we've already done this. Oh, to multiple pings. Okay, it changed. Okay, now we need to respond to multiple pings. Sent by the same connection. A Redis server starts to listen for the next command as soon as it's done responding to the previous one. Right, so we receive a command, we receive another one, but we need to, it's like synchronous, right? It starts to listen for the next command as soon as it's done with responding to the previous one, right? So it's like as long as while we're responding to the first command, we're not even listening to a second. I don't know Redis, but it might be that. This allows Redis clients to send multiple commands using the same connection. Okay. You can hard code ponk and as the response for this stage. We'll get parsing client, but input in later stages. The ping commands will be sent using the same connection. We'll get to handling multiple connections. Okay, so let's check this out then. We have on data here, right? We receive data, but this is when we receive data. How many times was this called? Once. So data, and then we have the whole data probably. I think in this case we need to do connection.write ponk inside of the data, or if this is the case, if we're receiving the entire data immediately, or if we're saving it part by part, we need to have like probably a different event, not data, but like data end or something like that. Let's just try it like this and see if we are responding to every pass. Yeah, to every command. So moving connection.write inside of the on data means request received, response written. There we go. That was easy. Just move on to the next stage. Already? You can either refactor your code or move on to the next step. Handle concurrent clients. So this step was immediately passed. We need to add support for multiple concurrent clients. In addition to handling multiple commands, Redis servers are also designed to handle multiple clients at once. So I guess this is just like inherently done with TypeScript. With Node.js actually. To implement this, you'll need to either use threads, or if you're feeling adventurous, an event loop, like the official Redis implementation does. That is weird. Let's see. I feel like we should do something about that. Yeah, test pass. Okay, select install. I feel like I need to see. I feel like we need to see some codes. You haven't completed the stage, but the test has passed. Threads and then change it. Okay, so it's probably, inherently developed, using the event loop that's like built in the language itself, so JavaScript. Most likely. Because this doesn't say, one connection only. This is a callback that gets executed every time we have a new connection. So out of the box, we have multi-connection support, right? Okay, let's mark it as successful, but let's go and see some code examples in TypeScript. Yeah, you see, it's nothing basically. Yeah, you see? Cool. Okay, moving on to the next stage, implementing the echo command. Nice. Echo is a command just like ping that is used for testing and debugging. It accepts a single argument and returns it back as an RESP bulk string. So we say ping and we return pong. That's the first, and then we say echo hey, and then we return, we get back hey. Cool. The tester will expect to receive a $3 carriage return, new line, whatever we receive, carriage return, new line as a response. Okay. So we have the data here, and I'm not going to write anything now. I'm just going to print it out to see what we get. There we go. So we see start to $4 echo. That's the actual command itself, and then we have $5 apple. If we show this or print this out as like a string, in between these, as we mentioned, is going to be like the carriage return a new line. So this means *2 or something, carriage return new line $4, which indicates, scroll back, $4 is the command. So the command is going to be echo. $5 is an argument that's set apple, and then we have of course $4 and then another carriage return. I'm just gonna do this. These are gonna be the carriage returns, echo carriage return $5 and apple, right? So if we take this data, convert it to a string, replaced the carriage return new lines with just remove them and pick out the third and fourth element, we're gonna have the command and the argument, right? Okay, let's try that then. I'm gonna say payload equals data to string. Parts is going to be payload dot split, and I'm gonna split based on carriage return and new line, and I just want to console log parts, so I want to see what we get. And I think we just need to pick out a specific element. There we go. Yeah, so we need the third one and the fifth one, right? So that's gonna be, the command is gonna be parts of, oh, wrong brackets, parts of 2 and 4. This is gonna be the payload, actually. It's not gonna be the payload. I'm gonna rename this to data string, maybe. I don't have a good name for it, but the payload is going to be parts, the fourth element. And what we want to do is return, what you say, damn it. I want to replace the surrounding. This one, I'm going to replace it with this one. There we go. Oh, okay, that was not what I had in mind. There we go. So instead of returning Pong, we want to return the payload back, followed by, oh, it's $3 now. You see that? and the carriage return. So it's not gonna be that, it's gonna be like $3, carriage return, new line, payload, carriage return, new line. That's the string hey, encoded as an RESP bulk string. Oh, it is the length. Okay, there we go. So we also need to calculate the length. It's not gonna be $3. It's going to be $, payload dot length, and then the payload. So if the command is echo, we want to do this. Otherwise, I don't know. Oh, it is going to ping us as well. There we go. So if the command is ping, we still want to keep that the previous connection. It's gonna be plus pong and carriage return new line, right? This was the original one, and if it's echo, we want to get the payload and return it back in an RESP string. All right, submit. Oh, what am I submitting immediately? Should have done tests. But yeah, there we go. Nice. So ping pong works, and also mango. That was the echo command. Yeah. Echo mango, we received mango. Beautiful. All right. This is fun, right? We're slowly implementing Redis. All right, so now we're going to implement the set and get commands. As you know, Redis is an in-memory database. It's often used for caching and, stuff like that. It does have more to it, but set and get is how we write and read into Redis. We want to set specific payloads based on a specific key. So it is a key value database. We want to set something with a key and a value, and we want to get something for a specific key. That's how we get the value for that key, right? So set receives two things, foo and bar, and get just receives the key. The response is okay for setting and the value for getting. Beautiful. The set command supports a number of extra options like EX, expiry time in seconds, of course. If we're talking about caching, that means set this value, but this value is going to be valid only for, 5 minutes, let's say. And that's in second. PX is in milliseconds and more. We won't cover these extra options in this stage. We'll get to them later. Cool. All right. Check this out then. We are going to... we're going to console log the data string. And I want to convert this somehow to a single string, not with the new lines. How to escape R and N when printing the data string. Search and replace. No, I don't mean that. How can I print the data buffer as a single string without new lines? I feel like there's a different way. Search and replace again, huh? Okay then. Let's apply this then, and I'm going to select theirs. There we go. Okay. I'm going to test, not submit, because we don't have anything to submit. There we go. So the data is start 3, set, banana, apple. right? The payload is going to be pretty much the same. Yeah. If the command is set, let's get the payload and log it out. Let's get the payload and log it out. Let's just make sure that, you know, we have pineapple. It's not going to be the payload. This is going to be the key. So we'll say the key is going to be the fourth part, and the sixth part is going to be the value, right? Console log the key and value. We should see pineapple, strawberry, or whatever, you know, we get. Raspberry, apple. Beautiful. All right, so now we need an in-memory data structure, which in this case is going to be like a dictionary to keep it simple. And let's name this DB then, right? It's just a plain object. And we'll say DB of key is going to have the value of value. And this has any, and I want to say it's going to be a record of string, and let's keep it string for now, but we'll see, we might keep it as any. I think it's going to be string, actually. I think it's going to be string. There we go. And we are setting this, and we need to return OK, and that OK needs to look like this probably. But instead of plus, should be just OK. And then if the command is get, the key is going to be parts, the fourth part always. There's not going to be a value. We should return the value, or let's just, yeah, value is the DB of that key, and we should just return it. Well, we need to return it in what way? Bar. It's just bar. Oh, there we go. As a response. So pretty much the same as the echo. But instead of payload, we're going to be using value, right? Yeah. There we go. All right, let's test this out and see if it runs. No. O is not a valid start of an RESP2 value, so it should be plus probably. Or no, it should be $2 carriage return, okay, carriage return. Basically like this, where the value is just okay, and the length is always 2. Let's try this now. Right? There we go, easy. Submit, and we are at time, man. This is so fun. I just want to keep coding this, but I'm gonna have to wait a whole week to do this again. There we go. Let's just do expiry so that we're done with the, you know, the whole stage, and then we're gonna, you know, get into the persistence next week. All right, expiry, last one. In this stage, you'll add support for setting a key with an expiry. I hope we can do this in 5 minutes. The expiry for a key can be provided using the px argument. It's going to be provided in milliseconds, hundreds. Okay, it'll then send a set command. And then we'll send a get command to retrieve the value. It'll expect the response to be bar. Then it'll wait for the key to expire, and it'll send another get command, and it should receive -1, a null bulk string, if, you know, the key has expired. Command arguments are also case insensitive. Interesting. Good to see. Good to know. Good to know. All right, let's try this. when we are setting, we're also have the px in this case. The main command is going to be set, but there's going to be an expiry, potentially, potentially, but we should check if the parts.length is greater than or equal to 6, right? I mean, it always going to be because we have the carriage return at the end, so I'm gonna say 7. If there are more than 7, then we most likely have an expiry, right? So let's grab, all of the parts are basically +1. So it's gonna be the 8th, it's going to be the expiry key. And the expiry value is going to be parts 10, right? Nice. Okay, I bet this is not how you're supposed to implement Redis, but you know, we're gonna try it this way until we know better. Okay, so if the expiry, damn it, wrong brackets, key is to lowercase, of course I want to go to lowercase because it's case insensitive. If it's px, then we're talking about milliseconds, and I'm not gonna do the seconds. Let's just do a const expiry is, I'm gonna say 0. Expiry is going to be, yeah, parse integer expiry value. Do it again, there we go. So of course shouldn't be const, should be let. Else if the expiry to lowercase is ex, that means we're talking about seconds. So I'm gonna do the same, I'm just gonna multiply it by 1,000, right? Times 1,000, because we're talking about that many thousand milliseconds. Cool. Now we have the expiry in milliseconds, and we need to figure out how we can store that expiry. Right now we only have this type of data structure here, and I think we need to expand on it, where the value is going to be the key, but the string is going to be changed to a different record, or no, an object actually, not like a plain, but an object where we have a value of type string and expiry of type date, right? Because we are going to create a date in this case. So we're gonna set the value to the value, but we're gonna set the expiry. So there we go. Actually, that's exactly what we want to do. Expiry is going to be a new date of now plus the expiry in terms of milliseconds. That's why we converted everything to milliseconds. I hope I'm right. And now when we return, or when we get the value, we want to check for the expiry. So we'll get the expiry and the value, and we'll say if the expiry for this key is greater than or equal to, like right now, we just want to, you know, return it. Otherwise, we want to return -1, right? That was what it expected to see. -1 return and a carriage return and a null string. All right, do you think it's gonna work? Let's see. If this works, I'm gonna be very happy because I gotta go in 5 minutes. No, it doesn't. Undefined is not an object. Oh, of course, easy fix, no big deal. db key dot expiry. Was it? What? Oh, of course. There we go. I keep messing the... Wait, hold on. What? Oh, the key is not defined. Ah, there we go. Okay, so let's just console log the parts here because we have an issue with the way that we unpack the commands. There we go. So, oh, we have 0, 1, 2 is for the command. 3, 4 is for the key, which is here. That's weird that it doesn't give us. 4, 6 is for the value. 8 is for the expiry key, and 10 is for the expiry value. That's exactly what I have here. But what is the undefined is not an object? Oh, DB is not an object. Is it? Am I missing something here? No, I shouldn't be missing something here. DB key, of course it doesn't exist. Oh yeah. Okay, check this out then. Yeah, I gotta do this then. Got it. I shouldn't do connection right here. I should do connection right here. And I shouldn't do this here. I should, actually, yeah. Equals a new object with the value. I know that is missing, so we should make that as an optional argument and as an optional property. There we go. And if expiry exists and it's greater than right now, that means it's valid. Let's do this then. This should work. No, it doesn't. Expiry key doesn't work. Oh, look at that. Maybe it's... I think it should be at least 10 though. Technically it's 11. Come on, I have 2 minutes. Okay, something passed, something didn't pass. But I don't know what it is. There's a debug true in CodeCrafters that we can see more details. Oh, expected simple string or bulk got nil. I got nil, but should have gotten mango. If the expiry exists. Let me just write this out. Value expiry. Do I have any console logs? I don't need the parts anymore. And I'll keep the data. Okay. Oh, there we go. So it's blueberry and undefined. So it is undefined. If it's undefined, there we go. Okay. This is different. Yeah. There we go. If the expiry exists, that should be the case. I should just refactor this. If the expiry exists, we need to... I'm gonna switch this up. If there is no expiry, then just... oh, damn it, no. If there's no expiry, then write the actual value. Or... this. If there is no expiry, or there is an expiry but it's greater than right now, that's when we return. Otherwise, we just return -1. Let's run the test and let's see. There we go. There we go. Nice. I'm gonna submit, but I'm not gonna do the console log here. There we go. Running tests. So there we go. The first section or all of the stages are done. I feel like this is going to be really, really, really cool. Yeah. Back to catalog. We're done with the whole, like, all the stages. Nice. We're going to continue with RDB persistence next Wednesday. So this was super fun. It's the first official episode, so I want to hear some feedback from you folks of how we can improve this. So please join my Discord, and yeah, just let me know how you liked this episode, because me personally, it was super fun. It was super fun, and I want to keep doing this, but I want to hear how, or like what you think about this. So yeah, drop a line in Discord. Thank you all for watching. I'm sorry that I have to leave like right now, but yeah, I'm gonna see you all next Wednesday. Actually, no, I'm gonna stream this Friday at 9 a.m. EST at the same time, but it's going to be a different project, and it's gonna be a fun one. It's gonna be a really fun one. It's gonna be a new project, okay? Not the AI stuff that we did. All right, thank you all for watching. I really hope you enjoyed this one, and I'm gonna see you in the next one. All right, take care. Bye.